Well, not yet, not yet.
I'm
Oh,
recording.
you're recording.
Okay. This is Team 12. I'm John.
Didn't happen.
I'm Mohammed. And we have another member, Gabby, who wasn't able to make it because she has final today. So what we have here are 3 proximity sensors facing upward. And our original approach was that we set a certain threshold. We programmed each sensor to have a certain threshold. And whenever the ball rolled over the sensor, it would throw an interrupt. The reason we have so many Arduinos is because the Arduino only has one TWI bus, which is what the sensors are using to communicate.
And you couldn't change the address?
No, we tried getting a software TWI to get going, but it only allowed us to get an additional TWI bus.
Mm-hmm.
And we have this Arduino over here because we realized that if we have the sensor and the servo connected to the same Arduino, the servo wasn't able to draw enough current. So we have an Arduino specifically to power the servo.
You could use the regular power supply.
We could, but
okay.
Money.
So all right. So just so that you guys, maybe you can't actually see this design because you're standing over there. So right here, there is a proximity sensor, which just looks like a little board. It's sitting underneath there. It's going to detect when the ball is close to it. He's got 3. There's one here. There's one here that looks like it's not connected.
So I'll explain that.
Okay, and then is this one connected?
No.
All right, so it looks like there's 3 proximity sensors, 2 are for show.
So our initial approach was to have, so we would keep track of where the ball was depending on which sensor threw an interrupt. And depending on which sensor threw the interrupt, we would tilt the servo a certain way. However, we found that because the interrupts were being fired multiple times when the ball was over it, it was kind of hard to determine which way to tilt the servo.
So you had a debouncing issue.
Yeah, we had a debouncing issue.
Okay.
So what we ended up doing, because we had trouble debouncing, is we said, screw those proximity sensors. We stuck with this one. We have a reset mode, which brings the ball towards where I am right now, and then it'll tilt the rail, the minimum angle to start rolling, and then when this sensor picks up the ball, it'll drop for a scale factor of the acceleration and velocity.
Well, it's not going to know the acceleration. We're assuming the acceleration
based on
how far it's gone. So this is actually a very similar design to the design over there, except this team is not using an initial velocity of 0 and an initial position of 0 and all of that, but you still have well-known initial conditions.
Yes. Except
your conditions occur here. So this wouldn't work if you moved this an inch to the left.
Well, it should, because it's a scaled factor of what we calculated as the velocity acceleration.
Okay, but you'd have to make changes in code.
Probably, yeah. The scale factor would probably be different.
It would have to change, right? Interesting. So the other 2 sensors over there make it look nice and balanced.
That's from before.
That's about it.
So actually, we're only using 2 Arduinos right now.
Lots of sensors.
And you went through all the trouble to have an LCD display. Does that work?
Yeah, but I don't have the code for it. Gabby has
it. Okay, so
Gabby brought it in for fun, just to show.
All right, so the idea is throw as many PCBs as you can on the table. Make it work. All right. So are you ready to go with this?
Can we get like 1 or 2 troubles?
Why don't you pause the recording for a moment?